Good day and welcome to today's lesson. I am Ms M Chuene and I will be presenting on stoichiometric calculations based on grade 11 chemistry. Now, the lesson objectives for this is that by the end of this lesson, you should be able to recall the key stoichiometric formulas, which are those of volume, moles, and concentration. You should be able to identify the limiting reagent in a chemical reaction, use mole ratios from balanced equation to determine the limiting reagent, calculate the theoretical yield of a reaction, as well as calculate the percentage yield using actual and theoretical yield. But before we go into today's lesson, let us just take a quick recap of what we should already know by now. What we should already know is moles and molar mass. Now, when it comes to moles and molar mass, the number of moles is symbolized by the letter N. The mass is then symbolized by the small letter m, and the molar mass is then symbolized by the capital letter M, and the formula there is then N equals to mass over molar mass. All right, and you can also see the units of measurement there, where mass is in grams and molar mass is in grams per mole. Now, the next thing that you should already know is the molar volume at STP, STP being standard temperature and pressure. Now, the the volume then becomes the number of moles times that standard unit of 22.4. So this means that at standard temperature and pressure, 1 mole of gas then becomes 22.4 decimeters cubed. So that is the unit of measurement for that one. So those are the standards that you need to know. Now, the next thing that you also need to know is the concentration of solutions. Concentration given by the letter C, and it is measured in moles per decimeter cubed, and the volume is then measured in decimeter cubed. And then the formula then becomes concentration, which is C equals to N over V. Now, as you can tell, there are units of measurement which are there, and sometimes you are given different units, so you need to know how to convert from units, especially when it comes to volume, because you would oftentimes find that they actually give it to you in centimeters cubed, so you need to then convert to your decimeters before you do any calculation. So whenever you're given a question, remember to always look at the unit of measurement, then take it from there, so that you get the correct calculation. Now, another thing that you should already know is how to balance equations. So with balanced equation, what we do is that we balance our equation to then determine the mole ratios of our products in that balanced equation. So in mole ratios, what we normally use, because sometimes we work with gases, so mole ratios are also equal to volume ratios. So you might find that sometimes they give you a balanced equation, and we are now looking at Boyle's law, which then deals with gases. Then you would use volume ratios instead of mole ratios, but those mole ratios do also help you get volume ratios. So your mole ratio and volume ratios are the exact same, and you use the same steps to find them. All right, now let us get into today's lesson. Another thing that you should have a brief background on is limiting reagent, and that is what we're going to be focusing on in today's lesson, as well as your theoretical and percentage yield. Now, in terms of what a limiting reagent is, it is the reactant that is completely used up first in the chemical reaction, limiting the amount of product formed. Now, others would also say a limiting reagent is the reactant that runs out faster. All right. Now, one might ask, how do we then identify this limiting reagent? The first thing that you need to do is then convert the mass of each reactant to moles. All right, so you will also see in the examples that they do give you the masses of each reactant, so you do not have to worry about that. And if you are in the lab, you will obviously weigh those reactant to find what their masses are. All right, and then you use the mole ratio from the balanced equation. So you then, after having the mass, you're going to then use the mole ratio. You're going to then find the mole ratios. All right, then you're going to have to determine the reactant that would produce less product. All right, so you will have to, based on the ratios, determine which one would run out faster and produce less product, and that one will obviously be your limiting reagent. All right, now let us go into an example. An example here is that we're given 16 grams of methane, CH4, with and then the molar mass of methane, when we calculate it, is obviously going to be 12 for carbon, and then we add the 4 hydrogens, which is 12 plus 4, giving us a molar mass of 16 grams per mole. All right, then we look at the oxygen gas, which has been given. We've been given 64 grams, and to find the molar mass, there's 2 oxygen atoms, so then it is going to be 16 plus 16 for the oxygen, giving us 32 grams per mole. So that is our molar mass. All right, so here what we have is that we have our mass and our molar mass. Then from there, we have to write the balanced equation. Now our balanced equation is going to be CH4 plus O2 gives us CO2 plus HO2, and then obviously to balance out the equation, we are going to then look at what is actually in here. So we can see that in here we've got 1 carbon, 4 hydrogens. All right, and then when you go to the product side, we've got 1 carbon and 2 hydrogens. All right, so it means that we need 2 more, which is why this 2 is here. It means that we need 2 more. All right, and then we move over to the oxygens. This side we've got 2 oxygens, and this side we've got 3 oxygens. All right, so which means that we need 1 more oxygen so that the equation is balanced. Now when we start looking at it, if we put the 2 in front of our water molecule HO2, it then means that we have 4 oxygens for 4 hydrogens. All right, and then 2 oxygens. All right, so we have our 4 hydrogens. It obviously balances with the reactant. And then when you look at our 2 oxygens, there's 2 here, and then there's another 2 that makes it 4, and then therefore it means that we need a 2 here as well to have a fully balanced equation. So you look at each individual element and then you balance. All right, but these are just the basics of balancing the equation. You should have an idea of it. Now that we have our balanced equation, we need to go into the first step, which is to convert the mass to moles. All right, remember we've been given 16 grams of our methane. So what we're going to do, we're going to say our mass, which is 16 over molar mass over 16, and then we can see that here we have 1 mole. All right, and then with our oxygen, we have 64 grams, which have been given, and our molar mass is 62, and this gives us 2 moles. Now, looking at this before we go into the next slide, what do you think is the limiting reagent in this example that I have given you? Just look at it and try to tell me which one do you think is the limiting reagent. All right. Now let us go into the actual working out of this example. Now we're going to use the mole ratio. This is our step 2. So from the balanced equation, what we have been told is that we have 1 mole of methane reacts with 2 moles of oxygen. All right. So this is what we need to have from the balanced equation. This is what we need to have. And when we did our mole ratios based on the product that had been given, we found that we have exactly 1 mole of methane. And you see, as per the balanced equation, that is what we need. And we have 2 moles of oxygen gas. And as per the balanced equation, that is what we need. All right. So this means that both of these reactants are present in perfect ratio. All right. So I know some of you might be wondering, oh no, so what does this mean? This means that neither of the two, neither methane or the oxygen, is a limiting reagent because they're in the exact stoichiometric ratio which is needed for a full chemical reaction. So if one of them were to be slightly less, then that one would be the limiting reagent. So this one here is the perfect ratio, and none is a limiting reagent. Now, say for instance, this was changed up a bit, where we have 16 grams of methane still. However, our oxygen is 48 grams. All right. Now, you would think, okay, no, based on the previous one, obviously the oxygen is the limiting reagent, but let us first try to confirm that one. And remember, we first write our balanced equation. CH4 plus 2O2 gives us CO2 plus 2H2O. All right. Now, and then we go through with those steps again. We're converting the mass to moles. All right. Now we already know that our methane is 16/16, which is 1 mole. Now our oxygen then becomes 48/32, which gives us 1.5 mole. Right. So this is how much of our oxygen we have. And remember, with the mole ratio, this 1 mole reacts with 0.5 mole of O2. All right. So what we know is that it is not enough, because remember, from the balanced equation here, it needs to react with how many? 2 moles. All right. And because it needs to react with 2 moles, it is not enough for 1 mole of methane. So therefore, our oxygen is indeed the limiting reagent. All right. Now we're still going to use this very same example when we now talk to our percentage composition, which is our percentage yield. All right. So what percentage yield is? It is the efficiency of a reaction showing how much product has been obtained to what was expected. All right. So percentage yield, how much product did we actually produce versus what we expected. All right. So the actual yield, how much we actually produced, and the theoretical yield based on theory, what was then expected, and then we multiplied by 100 to then get our percentage yield. All right. Now, given the example that we just did, where we adjusted, all right, so the molar mass of hydrogen gas of water, sorry, H2O, it's going to be 2 into our hydrogen. Molar mass of hydrogen is 1, so 2 times 1 plus 16, we are then going to get 18 grams per mole. So this is the theoretical yield. All right. So this is what we then expect. All right. And then mass equals to mass times molar mass. All right, moles times molar mass, that is how much we get our mass. All right, so when we look at this one in terms of the theoretical yield, we want to then find the mass for our theoretical yield. All right, so remember, when we do actual and theoretical yield, we use it calculating the mass and not the moles, which is why we are converting into our mass. All right, so the theoretical yield, therefore, for the mass is then going to be 1.5 moles times 18 grams per mole. All right, obviously the moles and the per mole cancel each other out, and then we are then left with 27 grams. So this is the theoretical yield. This is how much water we expect to produce given these reactants. All right, now say for instance in the lab they say that no, we actually produced 24. Remember, when you are working in the lab, you have to weigh and compare. So you find that actually you produced 24 grams of water instead of that 27. So we want to find out how much of that we yielded. So what is our percentage yield? All right, now in a percentage yield, we're going to then take what is the actual yield. How much did we actually yield? We yielded 24 grams over what is the theoretical yield, the one that we used to get that we got using the moles, which is 27 grams, and then we multiply that by 100, and then we find that our percentage yield is 88.9%. All right, so this is then our percentage yield, which is not bad, and it does happen in the lab at times, and which is why we always calculate such things, because sometimes due to human error you might spill something in the lab, and you then do not produce enough product, or something happens and you find that you then do not produce the product that you might have hoped for, or the reaction goes on for too long. There's different reasons for the percentage yield being lesser, and it is quite common, especially when you work with lab products. It's very rare that you would find that when you are in the lab and you're working with product, your percentage yield is 100%. It is very rare. It will be closer to 100%, but it is quite rare for you to then produce 100% of what you are looking for. So that is it from my side. Thank you, and have a good day.